Okay. Hi, everybody. My name is Jorn. I'm part of the architecture team here at NeuVector. If you came to join NeuVector 101, congratulations, you're in the right spot. If that's not what you intended to do, it's a good spot to be. Just tell your boss you're busy working. This is not the natural color of my skin. I don't know why my camera is doing that today, but if computers worked all the time, I think most of us on this call would probably be unemployed. So again, this is a 101 session. If you're like, what in the world is NeuVector? We're here to tell you, I'm going to try to make sure that I squeeze this into 29 minutes and 59 seconds. So you can get going at the bottom of the hour as scheduled. It's generally an open format. I have a couple of things prepared. I'll be bouncing back and forth between pictures because I don't want to draw live hand, and a little bit of our interface. A little bit of housekeeping here. We do have the QA screen all up and open. I think I can see it on my screen. Yes, I can. If you have questions throughout this webinar, I encourage you to drop them in. And if we get a chance, time permitting, towards the end of this session, we could probably just come off mute and have some little bit of conversations. But without any further ado, let me get underway here. So I'm gonna try to squeeze that in that half an hour. We'll see if that works. Here's sort of what's going on in the world of containers, Kubernetes security, and that's the box that we're talking about today. These environments are spinning up more and more, sometimes for the right reasons, sometimes because, well, all the cool kids are doing it. Either way, containers are coming up more and more. And this is a true statement. Traditional security tools don't work very well in these environments, mostly because those tools are designed for environments that are far less dynamic and having all those changes all the time. And a lot of times, I think there's also just an approach standpoint. If you get anything from this conference, take my advice. I think from an operations standpoint, and then of course, as a child of that, a security standpoint, try to think about each and every Kubernetes cluster that you have as its own data center in a data center. And third, over here on the right-hand side, Kubernetes, the good news is it obfuscates some of that networking. The bad news is it obfuscates some of that networking. As we're going on, I'm going to be using the word Kubernetes sort of as a pronoun. I'm kind of including, container solutions like, Docker itself. But when I say Kubernetes, I'm also talking about whether it's in the cloud, and EKS, AKS, Rancher, OpenShift, Platform 9, whatever it may be. I'm just using Kubernetes as that word. And we're going to talk through two different sections, vulnerability management and some true runtime security. So I'm going to get to what it does, but because I know most or all of you are engineers, I know that if I don't start with how is it deployed and how does it run in your environment, you won't hear anything I'm saying until the voice in the back of your head asking those questions is quieted down. So real quick from the top, I'm drawn here a little pretty picture of my 5-node Kubernetes cluster, and NeuVector installed in there is a Kubernetes native application, full stop. It's easy to deploy as you deploy all the other applications inside of your environment. We deploy containers, pods directly, no sidecars. There are enforcers that are doing a lot of the network and process and profile protections. There's a controller we put in there as a container that's running an HA. You'll see in my picture, I happen to have drawn 3 of them. One is running, they're running an HA environment. There's no database at the back end and it stays memory resident. And then there's the web user interface, which in full disclosure is actually a reskinning of our API because everything in NeuVector is API driven, because of course it is. Scanners are also discrete containers that run inside of your environment. You notice I drew 2 here inside of my environment. There's no open source code in there. That's all proprietary to us. Very, very fast scanners. In fact, we've had some people that have their tip of the spear for deploying NeuVector was the speed at which they were able to do vulnerability scanning inside of your environment. As you can probably imagine, if you have very large repos and a very large environment, you can start to horizontally scale those scanners. The controller takes care of arbitrating all of that work. And then the only other container that spins up inside of here is the database updater, and that just runs on a cron job. By default, we run that in the middle of the night. You can change it for your environment. And a good segue from that is, in fact, because it's a Kubernetes native application, NeuVector can be installed in something that's actually quite air-gapped. This is yours. It's software. It's installed inside of your environment. It's not a SaaS. We're not stovepiping connections out to the outside world. And the only thing that really needs to talk to the outside world, and you could even proxy this, many of our end users do, is that database update. So There's no sidecars. There's no code injection in the back end. Very easy to install, very easy to deploy. There, I wanted to get that out of the way so you weren't wondering, what is this stuff? How does it work? And like I said at the beginning, I'm going to talk about the product in sort of two different sections, two different schools of thought. A thank you to Gartner for letting me sort of steal this triangle. I'm sure many of you have seen this. If not, it's a nice way to talk about security controls inside of any IT organization. NeuVector lives at the top of this pyramid. Again, I like the pyramid from an illustration standpoint. I personally disagree with how Gartner sort of leans in on, like, the most elite companies are doing the things at the top, and someday when you grow up, you'll get to do them. I think that makes it very easy to do those things today. And layer 7 network segmentation and behavioral controls are important. You should probably start with those, not end with those. Thank you for the shout out from them. We didn't pay for this, but it was nice that Gartner called out that NeuVector really was an exception in a sea of other solutions across your Kubernetes environment. So I'm going to start out with CVE management, vulnerability management, and the story that it goes through your pipeline. So this is where NeuVector lives. You're a developer. You're going to write some code, probably commit it to a pipeline. NeuVector can get involved right there from a vulnerability management standpoint. You could use Jenkins or CircleCI or any of the great tools from Sonatype to call out, check for vulnerabilities during the build, and then report that back to any developers. You need to fix this, or this is coming down the pike. Same with when you build that code into an image and put it into a repo. NeuVector is capable of looking at multiple repos, drilling deep, doing layered scans, and using that as admission control. You'll see I put here on the screen before getting either into your pre-production or your production environment. And at that runtime, really build time, and throughout the runtime phase, we're also doing image inspection, vulnerability management. You'll also see that we're doing CIS benchmarks both against Kubernetes and against Docker, and even doing those CIS benchmarks against OpenShift, which is something we helped Red Hat come up with, and those behavioral inspections. And as I promised, I'm going to head off over to the interface. This is NeuVector. You see on your screen. Let me even make this a little bit bigger so nobody has to tip their glasses down to understand it. I happen to be running NeuVector right now just in my little demo environment on GKE, Google's Kubernetes service. I've even got a couple of other environments federated up into here that I have on AKS. I've got another one on IKS. Again, because it's Kubernetes native, NeuVector can install on pretty much any container environment, and the interface will look the same. You'll notice that I do have these federated up, so I do have the ability to federate multiple clusters up inside of any given environment. That gives me more than just a top-down view from a single pane of glass and an environment. I also get to establish rules that are federated and can work across my entire domain. I'll show you what some of those rules are and how they work in just a moment. So let's go back to the main dashboard here. Because time is sensitive, I'm not going to show you all these things, but we get the ability to right away at the main dashboard in the morning, you can look and see what your security risk score is. And we can even give you some advice about how to lower that. Are you running containers that are running as root that don't need to be? Do you have some things in a privilege mode that shouldn't? Are you running containers or environments that have a number of CVEs that are maybe exposed in a way they shouldn't? That advice is very easy to see. I can drill down even to some of my top security risks inside of my environment, see where nodes are vulnerable, and even have a picture of some of the traffic that's running in and out of my cluster. And I can also, for example, dive back down into any other environment and look at what it's like. Back on to vulnerability management, let's go take a look at that vulnerability management report page. This is what it sounds like. I get a nice drill down from a cluster by cluster of all the vulnerabilities that are inside of this cluster and the effect that they're having on my environment. As you can see, I've got this CVE here. I can click on this, get the information. I can move out to possible remediation. I can download a report about this vulnerability or any vulnerabilities inside of my environment, get a nice detailed report. And again, I don't need that today. I get to see the impact of some of these CVEs inside of this environment. Let me go back to an environment that I know has more vulnerabilities. So when you're inside of NeuVector, that we're going to show you where those actually land. So you'll see when I turn on my key here, I can see that the little black rectangles are representing images that have that vulnerability inside of my environment. Red and green are both representing running containers with that vulnerability and where they are. Green ones say, hey, that vulnerability is there. NeuVector's got some extra protections and controls wrapped around that, which I'll show you in a moment. But now I can get a great deep drill down into what's happening in my environment. For example, if I want to go set up a filter, again, I'm doing that inside of that build process, but maybe I'm a developer. I want to come in here and look at all of the high sevs that do have a fix, maybe in a namespace that I care about. Now I've got a report that's relevant to me, that's got high priority things that I can fix inside of my environment. I know where they are. I know how to fix them. I also can do, a policy standpoint, admission control. So admission control is just what it sounds like. It works the same in Kubernetes. What we're doing is we're using these reports to sort of gateway against, if you want, how things are deployed inside of your environment. I'm going to scroll down here and do a little bit of a shout out here. If you see some of these things and they look to you like pod security policies, it's because they are. NeuVector's always had these PSP-like controls inside of it. And if you're worrying about what are we going to do now that PSPs are being deprecated inside of Kubernetes, your answer is here. It always has been. And we've actually done some really good webinars. I've got some blog posts and some very good details about how to react to that PSP deprecation inside of your environment. But a really good example for doing maybe an admission control rule might be something like this. You'll see I'm going to set up a rule that says, here's how many high sev CVEs I will allow in an image that also has a fix. And I might say, well, that number is 0. I don't want anything in my environment that has a fix. But as an administrator, maybe I say I'm a kind of benevolent God, and I will give everybody 2 weeks from when the fix was available to get that out of the environment. So if anybody comes into this environment, I can nail that down to a particular namespace, the whole organization, just this cluster. When somebody tries to deploy an image at this point that has a high sev CVE for which a fix has been available for more than 2 weeks, they will get a report back. You cannot deploy this. It's broken this rule. Here's where to go fix that. Very handy inside of this environment. But if I go back to my vulnerabilities page, wait for this to load. Live demos. There's a bunch of other people using this environment right now too, so I should probably scale it up. Remember that report I gave just a little bit ago where I was nailing this down? Well, maybe I want to go in here as a security admin, ops, CISO, whatever it may be, and go look for high sevs that don't have a fix. Behold this report that I have here. Now remember, this is just my little light demo environment. There's not really much in here, and I deployed this recently. Most of these things are up to date. I did not litter it with a bunch of old CVEs and bad patches just to scare you. It's scary enough in real life. These are CVEs that exist in this environment running today that don't have a fix. They are identified. So we're sort of back to this thing. Vulnerability management is, what are we going to do about this? I might have lots of vulnerabilities. I've told my developers, please go address them. But I know you believe me because you've heard this. Agility is usually beating security, and you don't want to be the security department of no. So your devs might say, I don't have time. We'll get around to it. Or like you saw before, we know that these are these CVEs. There's no way to fix them. So if I take away all that vulnerability management, what I'm left with is something else. And I want to, as an aside, our cute little cartoon here, vulnerability management is important. You should be doing it. I'm not saying don't do it. It's part and parcel to our solution, and there's a reason for that. But vulnerability management is something that, from a timeline standpoint, is now and in the past. If you rented or got a car that didn't have a rear view mirror, you bring it back. It's actually the law in most states that you have to have a rear view mirror so you can see what's behind you. But vulnerabilities are things that have to have been discovered by somebody else and tested and proven and reported and pulled into your database and then scanned. Then you have to go do something about them. It's a best practice and has been for a long time in most other traditional environments to also look forward. Look at what's running inside of your environment today and into the future. And that's by looking at processes and network traffic and protecting the network at the front. And that is why we're also going to look at the other part of this pyramid. It's the second half of the solution up at the top. And that's, looking at automated firewallish kind of protections, behavior-based controls, and doing micro segmentation inside of your environment. So why is this different? What's special here? Well, this might be some Kubernetes 101 for you, but I've even found some people who've been doing this for a while and you're sort of like, I forgot about this. When we started rolling out container solutions and then thusly, control plane kinds of things like Kubernetes, the good news is, well, the network is flattened out and I don't have to worry about networking because that's complicated. Well, the bad news is the network is flattened out and I can't really see it. Even with my CNIs and my security policies, I'm really only making assertions about what is supposed to happen in my Kubernetes environment really at layer 3 and layer 4. You are unable to see the network sort of on the wire, especially in east-west traffic inside of a Kubernetes cluster. It's obscured to you. That's just a fact. I get a little bit of vision, north and south, ingress and egress controls, but a lot of that is also very limited in visibility. And most people who are looking at that traffic are actually using traditional next generation firewalls wrapped around that Kubernetes cluster. The thing I said was actually sort of like a data center in a data center. Well, this is, if you're going to take anything away from today, this is the big difference here. NeuVector is able to show you your entire network traffic, yes, east and west, inside of your cluster, all the way up through layer 7. So we get the full OSI stack, and that now gives you the ability to use that information, block when you need to inside of that Kubernetes cluster. And now I've got the ability to start, again, doing some of that behavioral learning. Remember the pyramid from earlier. I can model my applications, understand what's allowed inside of my environment, create those as policies, and then I can start to immediately begin to monitor against that. And if I want to, go into a mode where I'm actually protecting against anything that is not explicitly allowed. This also gives me, remember how we had unpatched CVEs? Well, now the only way to exploit an exploit is to hit the network. Well, if I'm not allowing that to happen, unpatchable CVEs can't be exploited. Also, zero-day threats, which nobody found. You don't want to be the one to discover it. Let your competitors get hacked and report CVEs. That's a lot more fun. We also get the ability to do things like actual packet capture inside of a Kubernetes cluster. For a lot of incident management, that's gold. If you've got a monitoring department inside of your organization, it's like, we aren't able to do packet capture inside of this production cluster. NeuVector does that for you. I'm going to go back to the interface and show you some of these very quickly, but I do want to explain a couple of concepts that we deploy inside of NeuVector, right? And that relates to that process and network controls. And there are 3 modes that you can set the elements inside of your cluster. And this isn't just cluster-wide. You can narrow it right down to a container or an image or a namespace or any groups that we have inside of the environment. And the first one is Discover mode, which is aptly named. It discovers what's happening inside of your environment without intruding whatsoever on the applications that are running or any of the deployment. Key point here, when NeuVector fires up, it's in Discover mode. You could install NeuVector in your Kubernetes production cluster right now, and no one would get mad at you because you wouldn't be stopping anything. What's actually happening is it's going to discover your applications. What's the communication betwixt either containers and pods inside of your cluster, in and outside of the environment, and again, up through the entire OSI model. So I'm not just going to say, hey, it's port 53, it must be DNS. That kind of mistake is how DNS tunneling attacks work. We're going to know the actual protocol and nail that down. Even if you had, say, a service mesh inside, you could put some micro-segmentation in there and say, it must be using the service mesh. If I'm using PCI-DSS, I could say, look, this is my stuff that's under the purview of PCI. I know that they're communicating in relevant parts of my environment and are communicating outside of them. And then once I've used that mode to discover some of the rules that I have in my environment, I can then flip any elements I want, again, via the GUI or programmatically over to a monitor mode. Now, monitor mode stops learning, but will start to alert you in the interface and whatever SIM you've got plugged in, be it Splunk or Datadog or PagerDuty or whatever it may be, to anything that is external to those explicit rules that you either did in Discover mode or you wrote them yourself. Most of it's done in Discover mode. Here's what happens once you've got this environment in Discover mode. You have now set up a beautiful zero trust environment. Anything that isn't supposed to be there will at least give you an alert. And the primary intent of this really was to do a dry run against throwing things into protect mode. So in monitor mode, what I can do is, once I've established these rules, I know this is the way my application is supposed to behave, I can start monitoring for anomalies. And if I see them, if I see a process or a network connection isn't there and I look at the alert, I can go back to my application owners. I can say, Is this normal part of the application? Do you want this here? If yes, I could write that back as a rule manually, and then I could take environments that I would like, parts of my environment, and put them in protect mode. Much like monitor, but this time in protect mode, something that is not explicitly allowed is much like an next generation firewall. There's an implicit deny any at the bottom. It will not be allowed. So now I've got a nice shell of protection around my environment that's actually very easy to set up. It's very programmatic. And the nice thing about doing it this way, which was a tried and true way we've been doing in the IT for 30 or 40 years, is the calorie burn from your administrative staff is a lot lower. When I've said, this is how my environment is supposed to behave, it's locked down, I can report that to my auditors, my management, my customers. When I wake up tomorrow morning, that environment should still be the same. I may wake up tomorrow and have new CVEs I have to chase, but now I've put that nice shell around it. And when changes are happening to these rules, they are because of things that we as an organization have systematic. Oh, the application's getting a new deployment. Let's go check it, put it through the system, and run that from a dev test over back to a production environment. I'll show you how some of that works as I look at the clock. So this is a map of all the connections inside of my Kubernetes cluster. You can see a lot of these very handy lines. It's even handier when I turn the legend on and you know what the colors of the boxes mean. So I've got several clusters. You can see I got containers inside of here. Blue ones are in that discover mode. Purple is in the monitor mode. Again, no longer learning, reporting on anything that seems weird and not allowed. And green ones are in protect mode. You won't see very many, you won't see lines other than blue between green containers. I'll show you why in a moment. So blue lines are things that are deemed as normal, right? If I click on any one of these lines, I can go see a connection that just happened inside of my environment. And I know that not only has this happened, but because it's blue, there was a rule already written that says this is okay inside of my environment. If I see orange lines, that's NeuVector saying, hey, there's no explicit rule for what just happened here. Dear human, dear sim, what do you want to do about this? I could say, that's awful. Maybe we should stop that. Maybe we're under attack. Or I can say, whoops, we should have written a rule around this. That's completely normal behavior inside of this environment. I could deploy that rule right now and never get those alerts. We do color things as major violations and high risk network connections because we do have a built-in list of known attacks out there in the world to say, not only was this not allowed, it looks really scary, please pay attention to it. But what you won't see inside of here is a color of a line for something that happened that wasn't in that explicit allow risk rule between protected containers, because it doesn't happen. What's important here is when you're in protect mode, it isn't a, oh, alert, attack. We prevent it right at the wire, east-west, inside of the cluster. One more way to look at that as I go back to the interface, I'm going to go look at groups. My opinion, this is where the work gets done inside of NeuVector. Now, remember with our traditional environments, and I'm doing security, I could, as a firewall admin or whatever, maybe I could go, oh, here's this range of IP addresses or this application stack. It's generally pretty static. I can bolt that down. As you know, in a container environment, containers are coming up and going down all the time. That's generally the idea. A container may need to be replaced and it shows up on another node. So me saying this node is this, unless I'm explicitly writing that to a particular node, it's really hard to keep track of things and write policies against things that are common. NeuVector solves that problem by the use of what we call groups. Most or everything inside of this particular environment is put into these auto-generated groups inside of NeuVector. We're narrowing them down by the application name, the namespace, and they're very easy to drill down to. And you can also create your own groups, right? I could add a group that does say, hey, it's this particular namespace, or it's coming from a domain with a reverse lookup, or I could use wildcards and Boolean logic to say, this is this group, this is this application. What's nice about groups is they're the things that you use to apply policies to. So I've got some things in a demo environment that we've named demo, and I could just type this in here, roll this down and go, oh, look, here are all the things that are inside of my demo environment. And I can see that I do have some rules. If I click on this group, I can see, look, this group has learned some things. Here are the network rules that it learned. So these are explicit allow rules inside of this environment. All of these were learned. This one looks like it was user generated via that process you saw earlier. Same with process profile rules. So we're looking at the processes that happen inside of the environment and writing rules for them in discover mode. If I put this into monitor mode, and this group happens to be in monitor mode, I'm going to get an alert anytime anything that's extemporaneous to these rules occurs in this environment. If I put it into full-on protect mode, if it's not one of these allow rules, it's not going to happen. So even from a procedural standpoint, you'll notice, look, I've got bash here. Somebody's been shelling into containers. Maybe because we're a modern DevOps organization, we really don't want people SSHing into containers to change things, because of course they should be changing the image. I could take this rule and get it out of here. Now, because it's in monitor mode, every time Carl's SSHing into containers, I'm gonna get an alert and go, Carl's changing stuff in production again, go talk to him. I could put it in protect mode, and I guarantee you nobody will be able to SSH into those containers again. So not only am I sort of protecting from weird, scary things in the outside world, I could start to, if you want, model some behavior inside of this environment. Extremely powerful. And as I get towards that bottom of the hour with the promise I'm having a hard time keep it at the bottom of the hour, I do want to point out something very important to lots of organizations, especially, let's say, if you're running up against a SOC 2 audit, where your auditor might say, where's your data loss prevention inside of your cluster? NeuVector comes running in with that answer. So I'll show you, we have DLP sensors. Again, because we're able to see that full stack, I can write up a data loss prevention routine just using regular expressions, apply it to those parts of my environment. And now I can say, and to my management, my customers, and my auditors, yes, I have DLP inside of my cluster. Again, because we've patented that approach in NeuVector, this is a unique solution for DLP for doing full true protections inside of your environment. So as a wrap up, we're Kubernetes native. Again, we're not running as a SaaS. I'm not still piping into your connections. There's no data about you leaving your environment. You can completely air gap that environment if you want. It's full life cycle. I can codify all that security, get it over to other parts of my environment, even with API calls. And we're extremely scalable. I'm talking about perhaps clusters with hundreds of nodes with them and thousands of containers. Bring that challenge on. And we're doing actual runtime security, not just deploy time security. We're automating that DLP. We're giving you full information across that entire stack. And that's what you get out of NeuVector. And and as a parting shot, it's very easy to deploy. If you want to get into a proof of concept inside of your environment, build a new environment, put it in your production environment, it's very, very harmless. We're happy to do that for you. We walk that walk with you on a proof of concept. We can help you prove it to your environment. And if you wound up with NeuVector in your environment and you said you didn't want it, because we're Kubernetes native, it's very easy to pull out. There's no code injection, nothing that we leave behind. So I thank you. In respect to your time, I've dropped to the bottom of the hour. My name is Jorn. If you have any other questions, we have some fantastic blogs on our website. Check out our YouTube channel, where we've tried to, some people like myself, I like to watch things in motion and learn that way. And if you need to reach out to us, we'd love to hear from you. That's info@neuvector.com, info@neuvector, NEU. I appreciate your time, and I'm going to wrap the chat because I promised you that I would. Have a great day, and thanks for joining.